All right, so let's talk about slopes of implicit derivatives and tangent lines. So this is 2.5b, you can call this slopes and tangent lines of implicit derivatives. Slopes and tangent lines of implicit derivatives. So, when we find dy dx, it equals dy dx equals the slope of a tangent line of a function, of an equation, of a graph, I should say, of a graph. When we find dy dx, what we are finding is the function of a slope of a tangent line. A slope of a tangent line, an equation that can tell us a slope at various points. So if I give you an equation like, oh, what's a good one? Let's say we do the equation of an ellipse. X squared plus 4y squared equals 4. This graph looks like this. It's an ellipse. This equation is the equation for an ellipse. Okay. Equation of an ellipse. And what I want to find is if I choose a point on this ellipse, like if I choose the point right here, and the location of this point is square root 2 negative 1 over square root 2, I want to know what is the slope of a tangent line at that location of my point. Find I'm going to do this. Find the slope. Find the slope at root 2 comma negative 1 over root 2. It's a location of a point on this graph, right? So I want to find the slope at that location. What is this slope equal? What is the value of that slope? What is the slope of that tangent line? And the thing that's going to tell me that slope, is dy dx. Dy dx is going to tell me that slope. That's my derivative, dy dx. So with these implicit equations, we're doing the same thing we've done before. We're finding slopes of tangent lines. We're finding equations of tangent lines. It's just now we have to do the derivative implicitly. We have to find and isolate this dy dx. So your steps: 1, take the derivative. Take dy dx. Take ddx of the equation, ddx. Isolate dy dx. Get the dy dx part by itself so you can solve it. And then 3, you're going to plug in the point the point to x and y in the function you get in dy dx. You're going to plug in the x and the y, because sometimes we have x and y's. So we're going to plug in the x and the y, and we're going to get the slope at that point. So let's give this a try. Let's do the ddx here. So do my equation, do my derivative. This is going to be 2x plus derivative of this part here. I do my chain rule, my power rule. Take the 2 times the 4, make it 8 y. And every time I do a derivative of something with a y, I end with dy dx. Derivative of 4 is 0. Okay, 2x plus 8y dy dx. All right, so easy enough. Now I just have to rearrange, get the dy dx part on its own. See if I can solve this. So let's minus 2x on both sides, minus 2x on both sides. And then I'm going to have to divide by the 8y, so I'm going to get 8y equals, 8y dy dx equals negative 2x. Divide by 8y on both sides, and I get dy dx equals negative 2x over 8y, which I could simplify to be negative x over 4y. Let's do that. Okay. Good so far? So I got our derivative. We have our derivative. We isolated dy dx. Now I'm going to take this point here, this square root 2 negative 1 over 2, negative 1 over root 2. This is x and y. I'm going to plug it in to here. Plug in my point, my x, my y. Actually, let me rearrange. Let me get this one here. This is x and y. Take this one. Plug that into my x and y here. And when I plug it in, I'm going to get a value, and that value is going to be the slope. So let me do this. dy dx is going to be equal to, I'm going to get negative square root 2 right, over 4 times negative 1 over root 2, negative 1 over root 2. Right, so I just plugged in my x and y, and now I've got to kind of deal with these fractions, the situation here. Simplify, this is just, simplifying negative radical 2 over this 4 times this piece here. This is like a 4 over 1, so I can really make this negative 4 over radical 2. Right, you can think of it like that. My negatives can cancel. And then I have a fraction over fraction, and when I have that, I do my little flip-a-do. So it becomes radical 2 times radical 2 over 4. Square root of 2 times square root of 2 is 2 over 4, which becomes a 1/2. So the slope is 1/2. Now, if you have a question about this part here, remember, square root of 2 times square root of 2 becomes square root of 4, which is the 2. Question? All right, so we're getting the derivative, we get the slope, right? Can I show the steps I wrote? Oh, yeah. Let me zoom out. Right, we did our derivative, we took dy dx, we got this equation here. Then we isolated dy dx to be right here. Here's dy dx. This is step number 2. This is number 1. And then number 3, I plugged in. Get the dy dx, isolate dy dx, plug in, get your slope in the end, your numerical answer for the slope. So that slope, positive 1/2. And you see, if you look at it, if you look at our graph, you see, yeah, that makes sense. Looking at where the location is of the graph, we see the slope value being positive, and it's like a low slope, 1/2. Visually makes sense. Like visually we can identify that slope is correct. If you get something crazy, if I got -5, that would be obviously wrong. Right? We can like do a sanity check where we look at the slope, look at the graph, and we look at our answer, and we see, does this slope seem to make sense with this answer? Visually, does it make sense? So that's a good way to check yourself. Look at it, do a sanity check. That's my answer. Look at the picture. Does that picture make sense with my answer? Okay. Let's do one more. And if you need to see it again, let me know. Another example. In this example, we're going to write an equation. Write the equation for the tangent line of the function at the point 3, 1. And the equation is going to be so here's our equation. I want to know what is the tangent line. Write the equation for the tangent line of the function at the point 3, 1. Here's our equation. We can go to Desmos and plug the equation in to get a visual of what it looks like. So we can go to Desmos and get this graph. Let me head there now, because it's very helpful to find a little visual of what this equation is. So let me go to Desmos. I've got 3 times x squared plus y squared. Your calculator cannot cannot do this. I mean, unless you have Desmos on the calculator, on your phone. I mean, if you have Desmos on your phone, Desmos just fine. Equals 100 x y. And the reason your calculator can't do this is because it's not really a function. It's an implicit function. Most calculators can't do implicit functions. But here's the graph. Woobity, woobity, woobity. It's called a lemma, lemon scale. Lemon skate, actually, lemon skate. Various family of functions that do this little curvy business. And so the point we're looking at is 3, 1, which is right there. So you see that point is on the graph. And so we're looking for the tangent slope, the tangent line of this point here. Okay, this is our tangent equation. We're looking for dy dx, the slope, and looking for the tangent line here. So let's take a look and let's draw that. I'm going to try to draw this. Actually, let me see if I can do this, everyone. Hold on. Oopsies. Can I take a screenshot and put this in here? Is this going to let me like insert something? No, I don't think it will. All right. Well, fine. Let's go back to our whiteboard. Let me try to draw this. Whoops. Try to draw you. So our graph looked something like, we got this here. We had a little woobity, woobity, whoop. And our point 3, 1 was like here. 3, 1. So I want to find the equation of this tangent line going through this point here. Like a woobity and then a woobity. It goes down and across. It's not a great picture, but you get the idea. So that's my graph, that's my equation. I want this equation of the tangent line, so I need to know the slope, and I need the y equals mx plus b. When it says equation, right, that's what we want. We want the y equals mx plus b graph. So to do that, we need the m and the b. To find the m, I do my derivative. So let's find d dx of this whole equation. Now this is a little complicated, right? There's a lot of pieces here, so we're just going to take it step by step, right? One piece at a time. So my derivative of this whole piece, the 3 is going to stay, and I have a few layers here, right? First thing is I have this outside squared. So I'm going to do the derivative of the outside, leaving the inside alone, right? Just do one step at a time. Derivative of the outside, I take the 2, bring it in front. 3 times 2, that's going to be 6 times x squared plus y squared to the first power, because I reduced my exponent by 1, did my power rule, bring it down. So that's my derivative. That's derivative of the outside times the derivative of the inside. Now I have this inside, and I do each derivative of this piece. I have this x squared piece, I do the derivative of that, plus this y squared, I do the derivative of that. So this is going to be 2x plus 2y. I did a y, so I need to have a dy dx. Okay? Derivative of the outside, squared part, times the 3 is 6, and the inside alone, times this derivative of this inside piece in here. So that's that part, equals, now I got another part over here. The 100 is going to stay. And I have another product rule situation where I have the x and the y. So I got to do first times derivative of the second, plus second times derivative of the first. First times derivative of the second. So this is going to be derivative of x times dy dx, first times derivative of the second, plus second times derivative of the first, that's just y times derivative of x is a 1. So that's that part. If you'd like, I can put the 1 here. That would make sense. So I got a couple dy dx's. I got to rearrange this whole situation to get them isolated. And again, we have situations where we have some parentheses and some multiplications. So I'm going to take this whole piece and distribute that, and the 100 and distribute that. Okay. Oh, wait, I can't just do... That's fine. That's fine. We'll do that. Yeah, we'll do that. Okay? All right, so 6 times 2, that's going to be 12. Oopsies. 6 times 2, that's going to be 12. X squared plus y squared times x, or I should say maybe 12. I should do the 12x in front. 12x. So I did the 6 times the 2x times this thing. This is all together. I could like do a foiling here, but I'm going to leave this x squared plus y squared as its own piece because I don't really need to simplify. I don't really need to separate the x and the y here. Plus 6 times this is 12y dy dx times x squared plus y squared. That's all fine. Equals 100x dy dx plus 100y. Everyone got that? All right, let's rearrange. I want to get this dy dx with this dy dx. So let's see. I'm going to minus this whole part and minus 100y and move it over here. So this part's going to go over here, and the 100y part's going to go over here. So I'm putting the dy dx's together and everything else on the other side. 12x times x squared plus y squared minus 100y equals 100, whoops, not 1,000, 100x dy dx minus 12y dy dx times x squared plus y squared. Now I factor out the dy dx. I'm going to get 12x x squared plus y squared minus 100y equals dy dx times 100x minus 12y x squared plus y squared. And now I can divide this whole thing, all this blah, 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 over here. dy dx, dy dx, dy dx equals 12x x squared plus y squared plus minus 100y over 100x minus 12y x squared plus y squared. Whew! That's complicated. Let me zoom out so you can see all the pieces I did here. Lots of algebra manipulation here, but nothing surprising, right? It's all, we're following the rules. We're doing distribution, we're subtracting, dividing, moving. it's just various big chunks that we need to sort of manage as we go around this. It's okay, Jessica. You'll get some homework tonight to get it working. So that was our derivative. Now I gotta plug in. What's the point? 3, 1. X is 3, y is 1. So x equals 3, y equals 1. Plug in. Let me do one more thing. dy dx equals, I got a couple minutes left. Let me just find the slope. 12 times x is 3. 3 squared plus 1 squared minus 100 times 1. And this whole business, you are just going to plug into a calculator. Minus 12 times 1. 3 squared plus 1 squared. Whole business, plug into a calculator. What's that? How else are you going to practice? It's going to be like 7 questions. Many. This whole business, plug into a calculator. And you get dy dx is, what does it say? 13 over 9. There's your slope. No pain, no gain, Lizette. No pain, no gain. All right, so I'm going to have your equations for the homework is just to find some slopes of various curves and tangent lines. Don't worry about tangent lines. We'll do that next time. Page 149, 25 to 35 odd. So 5 questions. 25 to 35 odd. Early questions are easy. I don't think they get much more complicated than what I just gave you. No, that's the most challenging one. All you're doing, find the slope, 13 over 9 here, for example. Get these equations. Well, the only way to make it is practice. All right? What I can do is, how about this? Would it be helpful to have some study sessions on Zoom? I saw that somewhere. At the end of, I can't do it today, but like, we can set a day, maybe Wednesdays. When do I see you? Maybe Wednesdays. How about this? How about tomorrow? Yeah, tomorrow after school. Wednesday from 2 to 3. After school. Same Zoom session, same class. Let's plan for that tomorrow. We can work on this homework together in class. Come back to the same class. We'll do this together. Woot woot. All right. Very good, everyone. But that's it for us today. In the chat, type goodbye. Once you type goodbye, you're free to go. Thank you all very much. Good luck. I'll see you tomorrow. And enjoy the rest of your day.